This is Nate here. In this video, I'm just going to go over how the Eclipse Light Engine works with cameras and resolutions, and what you need to know as far as setting stuff up like that. By default, you can use your own camera. You don't have to use anything related to the light engine. It's going to grab the current camera and go from there when it sets up the matrix. But there are some things provided to make it a little bit easier. The important thing to know, literally the only thing you need to know out of this whole video that'll matter in the long run, is when you change the application surface size, you need to call this function free lighting surfaces on the light engine itself. You got to make sure if there's no light engine existing, you don't have to do it, of course. But so just to be safe, you may want to do with light engine free lighting surfaces, something like that. Suppose you have a GUI object that lets the player change the internal resolution to increase performance or whatnot. Maybe you have settings like medium, high, whatever, ultra settings. That's where you would then call free lighting surfaces after you change the application surface size. So that's like the whole important takeaway of the whole video, is make sure you call that. Otherwise, it's still going to work just fine, but what's going to happen is the light surfaces are all going to render at whatever resolution they were already at, and you're not going to see a difference in performance, or higher or lower. Either way, it's not going to do anything. So if you initialize the game in a separate room, like when the game first loads up and you set up your camera, there's probably no lighting engine in that room. So if you have that situation, you don't even have to call this, because a new light engine in a new room is just going to grab whatever the current application surface is when it's created. So it's only when you change it and the lighting engine already exists, you need to tell that lighting engine, hey, we changed this application surface, you need to update your surfaces. That's all it does. So, and all it does is free them, really, and then notices that. So now there also are some built-in things to assist in this, so you don't even have to think about it. And like in the demo project, I use this increment render resolution, where you can page up and down and you can change it, and you can go up to 4K, go all the way down to just a pixelated mess. There's some default setup with this render width. I find it scales best off 720, and that doesn't mean you're running at 720 once you scale it up. It's just it clamps nicely within this range right here, which goes up to 4K, and it's going to hit all your major resolutions. Again, this could be adjusted to however you want. You could set it directly. You could remove the clamp. There's whatever options, but this is going to fit most modern situations. Like most all resolutions we're commonly dealing with, at least in HD stuff, it's going to be there. And when you scale it down, your pixel art, it will work just fine too. It depends, you have to have your camera and your view set up, otherwise you'll get some issues with pixel art. But for HD stuff, it's not a problem. And then these, the GUI stuff you can kind of ignore. That's just there to set up for the demo purposes of the light engine. And as you can see, it does call them in let's see, light engine core. There's this function down here, easier, in a knit window. This is what I'm going to import, a camera that calls this function. But this is it's going to just scale things according to your aspect ratio, and whether it's landscaped or not. So as you can see, it sets up the GUI, and you could totally remove that or do whatever. This is the boilerplate setting up your screen and resolution type code. So now I'm going to import that camera and just set things up. In the package that comes with Eclipse, there is a example folder, and I'm going to grab that camera out of there, and it has a sprite, and I want this navigate one. There we go. So in the room, I'm going to make a system layer, just generic. Throw the camera on there, and by default you can see the camera, it follows itself, but we're gonna make a navigate object for it to follow, and I give that sprite that I grabbed, and I want it to be able to move, of course. So we'll do x equal, there we go. I had it buffered there. Alright, cool. So there's some movements code, uses arctan and whatnot, and I can increase the zoom with the mouse wheel, and of course it's going to end the game that's convenient. And then the camera, I have it set to use that init window function. And what I do not want, it's just easier to record if it's windowed. So I'm gonna, the false is whether it's full screen or not. This camera is pretty nice. You can use it if you want for whatever. It'll do. It'll scale nice with pixel art if you use the right zoom size, because zooming with pixel art is a little different, but it uses bitwise, so it's a little faster and whatnot. And you could probably add screen shake and other things to it. So it's your standard camera. It's a type you would actually leave persistent throughout all the rooms too. So it's a decent camera. So I'm gonna put my navigate in here, and the camera is going to follow that. And that should do it. The one thing is the room's still pretty small, so I'm gonna make that bigger. There we go. And the navigate, I want him to, there we go, move a little faster. So that should do it. So run it. There we go. So I can zoom in and out. Camera follows it around. And I did resize these. These would look a lot better probably if I didn't squish them down so much in the other videos. And that's it. That's how you set up the camera. The camera's decent enough to use, or you know, again, set up your own. The main thing is, as I mentioned in the beginning, is call free lighting surfaces to actually change what you're rendering at. If you change it. If you don't change it, don't even worry about it. So.